The race is on while there's a window of opportunity to get everything ready and sufficient for man's future on the moon.
Enables public satellite operators to put their data available for free into the market.
Now you have SpaceX that's charging $1,200 to year. So it's a combination of this that sort of led to this exponential increase in satellites and orbits. Well, that's all fine, but have we actually reached an inflection point? What really do we mean by space safety? What are the components in it? This was a way to think about it that we got from a space safety workshop they attended earlier this year. And it was quite nice because it fits it quite nicely to operational resilience and environmental stewardship. So operational resilience being, well, how can you tolerate impact? How do you build for that? Impact tolerance, this is mainly around satellite shielding, and this is mainly to be able to cope with debris of the size between 1 to 10 millimeters, right? That's what shielding can help with. And that is, if you look at the encounter probability and how much damage and impact debris can cause, that's probably the highest risk category. Challenges down mechanical design and antenna design, because what if your satellite fails and it's tumbling? How do you still cope with that? So those are the sorts of things that we're thinking about here. The right is actually based on our studies we did. We took video off a GoPro that was flying amongst hang gliders and had a play at, well, how many hang gliders can you detect? So what you see on the right there is actually a set of an array of piezos used for, well, in this case it's used for creating droplets of fluid, but you can imagine transferring this technology where it's an array of sensors instead. The V sector, I would say, this is less about the propulsion, it's more about the maneuver itself. How do you select the right maneuver? So there are companies like Sage Tech.
To Mars, there will not be a system admin. In fact, we're doing a whole bunch of work with NASA trying to get rid of system admins, period. Which is only a good thing, I think.
But that comes down to, as you were saying, it's about having essentially containerisation of the applications so they can be moved around between universal processors as opposed to dedicated. The great thing when we first started getting mobile phone apps was they were written such that they ran when there was no network. Remember that? You used to have a phone app that would work when there was no network connection. Now, unfortunately, as network connectivity has become more ubiquitous, the app developers are becoming more reliable on, well, this app will always have a network, so I'm going to build it when it has, it only works if you've got a network, and you'll notice that more and more. When we go into space, there is no network most of the time. It's certainly not sure what you want to talk to. It's certainly not the speeds people are expecting, so again, we need to kind of flip back in that thinking too.
Okay, fantastic. And I want to pick up on the power bit, because Richard, you mentioned it earlier, Ben, you've mentioned it again. Richard, can you give us a little more on the realities of powering in space, be it solar, be it, you mentioned nuclear?
Well, I think if you're generating a lot of data or processing a lot of data, power is going to be critical. So we're going to have very efficient power solutions and very efficient power storage solutions that go with those power generation solutions. And I think that if we're looking at generating power at scale, then we're going to have to embrace the fact that nuclear power will bring a solution to the table for future exploration endeavors that gives you that power density that is really unsurpassed. So at Spaceport we are working on observing the Earth more effectively. So there's a concentration of scientists looking at how do we generate all of the data that we need to understand more about the evolution of the planet and the risks that we're facing. But we're also working on those technologies that will enable us to generate power more effectively in situ, will allow us to use resources more effectively in situ.
Fantastic, thank you. Chris, can we come to the UK Space Agency and ask how this features in your programs and what you're doing to support these types of endeavour?
Capability, but that comes with its own challenges in that you're pointing one light source at another light source that is millions of miles away, so you need to be very accurate to be able to get the throughput. So we're starting to look at that at the moment. If anybody's interested, come and speak to me afterwards and I'll point you through to my colleagues who are looking at that. New communications technologies to get us from here to the moon. Come talk to me and I'll point you into my colleagues who are running those kinds of programs. But they're the kind of footings and the sort of foundations for expanding our communications capabilities, not just for here on Earth, going to the moon and onto Mars. So we're looking at all sorts of new technologies, new types of antennas, new throughput methodologies, new processing methodologies in terms of communications to allow us to address some of the issues that we've talked about here on the panel this afternoon.
Okay, fantastic, thank you. I'm going to go to a couple of questions from out with now. Onboard data handling in satellites is vulnerable.
Space-Comm 2022 at Farnborough, near London in the UK.